Hello students, welcome to LearnGuru Classes. So last class we have discussed about factorization by grouping. Today we are going to see how to factorize the difference of two squares. So let's get started. So before that you should be acquainted with this formula where a square minus b square. So a square is a square, b square, and the difference between the two squares, the formula is a plus b into a minus b, and you are to implement this particular formula in all the numericals. Okay, so first example is x square minus y square by 100. So first and foremost task is you have to make the number square. Okay, so here as you can clearly see that x square, x to the power x whole square minus y square by 100. So y square by 100 we can write it as y by 10 because 10 square is 100. So this we can write it as y by 10 whole square. Okay, now it appears in the form of s square minus b square. So a square minus b square, the formula is a plus b into a minus b. So here we will write it as x plus y by 10 into x minus y by 10. Okay, so as simple as that. So second is x cube minus x. Now you see. Now you have to apply two concepts here. First of all, you identify whether all the individual terms are square or not. X cube is not a square, isn't it? And x is also not a square. So somehow you have to express this number in the form of a square. Now if you notice the two terms, you will see that x is common to both the two terms, right? So can I take x is common? X is common, and this we can write it as x square minus 1, right? We can write it as x into x square minus 1. Now x and this x square we can write it as x to the x whole square minus 1 is 1 square. So x square minus 1 square is difference of two squares. So this we can write it as x into x plus 1 into x minus 1. Okay, so the third sum is 2a to the power of 5 minus 32a. So what I have told you, first you have to identify the terms whether they are square or not. So 2a to the power 5 is not a square, 32a is not a square. So by anyhow you have to make it as a difference of two squares. So from this you can see that a is common to both the two terms, as well as 2 is there and 32. 32 is divisible by 2. So we can take this as 2a as common. So 2a, so I have told you 2a I have already written over here. Now you notice the terms here, what is there and what you have to write in the bracket. So twice a is already here. So a to the power of 4. So a into a plus a to the power of 1 plus 4, since a is the common base. So we can write it as a to the power of 4 minus I can write 16 into 2 is 32, so 62. 2a 16, isn't it? So 2a into 16, that is 32a. We have written. Now we can say that a to the power of 4 minus 16 can be written as a square minus 4 square, right? 4 square we can write. Now 2a we can write it as a square minus b square. So we will write it as a square plus 4 into a square minus 4. Now you see this particular term is also a difference of two squares, right? A square minus 4 can be written as 2 square. That is, we can express it in the form of this expression. isn't it? So this we can write it as twice a into a square plus 4 into a plus 2 into a minus 2. Okay, so this is how we have to see. After breaking it, again you have to check whether some term or any term makes a difference of 2 squares or not. So from here we have seen that a square minus 4 is again a difference of 2 squares. So this can again be broken into a plus 2 into a minus 2. Okay, so this is just a preliminary concept of this type of sum. Some advanced level of numericals are also there. So let's move on to the other examples. The next sum is x square minus 1 minus 2a minus a square. Now if you see, there are 4 terms over here. Okay, so from here you have to make the difference of 2 squares. Okay, so how to do? Now you have to use the concept of factorization by grouping. Okay, so what do? You make, suppose, such that they make a square. Okay, so suppose if I write x square minus 1 plus 2a plus a square, I can write x square is 1 and this I have taken as within one bracket. Now if you see, this is x square and this is the form of a plus 1 whole square, right? 1 plus 2a plus a square makes a plus 1 whole square. So this I will write it as a plus 1 whole square. Now it is of the form of a square minus b square, that is the difference of 2 squares. So this you can write it as what? X. Okay, keep the third bracket on so that you will x plus a plus 1 a plus b into a minus b. Okay, so this you will write it as x plus a plus 1 and this you will write it as x minus a minus 1, or you can keep it inside the bracket as well. Okay, so the second sum is 1 plus 2ab minus a square plus b square. Again 4 terms are there. So you have to arrange the sum in such a way that you obtain 2 terms that both of them are difference of squares. Okay, so this one, let us keep 1 as it is, and if I take minus, okay, as you have to make difference of 2 squares, that is negative sign should be there. So can I write a square minus b square minus twice ab? Now try to compare it with the given term that is given in the question. Minus a square within bracket minus a square minus b square plus twice ab. So if I take minus is common, so I can write it as a square plus b square minus twice ab. So this we can write it as a minus b whole square. Okay, so this is also a square and this is also a square. So how will you write? Give the third bracket 1 plus a minus b. If you give the third bracket, you will not make any mistakes, because after that you remove the bracket and take the sign as common. Okay, so 1 plus a minus b and this one will be 1 minus a minus b. So this you can write it as 1 plus a minus b and the rest you can write 1 minus a plus b is the final answer. Okay, now the third sum. So third sum is a little bit different. If you see here, x square plus 4 by x square. Now you have to factorize it or you have to make the difference of 2 squares. Now this does not seem to be difference of 2 squares. This is a square, x square plus we can write 2 by x whole square, but in between there is a plus sign. So what to do? You have to add and subtract some things so as to make it a perfect square. Did you understand my point? You have to add or subtract certain things so that you can make it difference of two squares. Okay, so how to achieve that? You see, this is already of the form of a square plus b square, right? So let me write it as this way, a square plus b square in this way. Now to make it a perfect square, like a plus b whole square, okay, so that is a perfect square. So to make it this, you have, suppose a plus b whole square. If I will write it as a square plus b square plus twice ab. Okay, so a square means x square is there, b square means plus 2 by x whole square is there, but this part is missing, right? To form a perfect square, this plus twice ab part is missing. Okay, so you have to add this part. So if I add this part 2, so a into x into 2 by x I can prove. But I can't write it as plus 2x. I have to subtract it so that you are left with only the final term. So if I do minus 2x into 2 by x, so plus minus it will be 0. So ultimately will be left with this expression, right? So you have to subtract this with this so that you are getting the, or you have the original term along with you. So this becomes as x plus 2 by x whole square minus 2, this you can write it as 2 square, right? 2 square, 4, 2 square. So this is a square minus b square. So you can simply write this as x plus 2 by x plus 2 into x plus 2 by x minus 2. Okay, so this is the third sum. So let's move on to some other examples. The next sum is a into a minus 1 minus b into b minus 1. Okay, so this is one term where product is there and this is another term. So you have to expand these terms to make it or form it as a difference of two squares. Okay, so this a square minus a minus b square plus of b. Okay, plus of b, yes. So a square minus b square we can take here and minus a minus b. Okay, you can take here. So a square minus b square you can write it as a plus b into a minus b minus a minus b. So a minus b you can take as common. So this will be a plus b minus 1. A minus b into a plus b minus 1 is the answer. Okay, so here this part you are getting the difference of two squares and you take the common factor. So here you are utilizing the concept of both taking the common factor as well as difference of two squares. Okay, so let's move on to the next sum, that is x to the power of 4 plus 5x square plus 9. Three terms are there. Okay, so somehow you have to make it as a difference of two squares. Okay, so that can be done from this type of terms. If you find, always try to make perfect squares out of it by adding or removing some terms or breaking the terms. Like here we will break the term. Okay, so x to the power of 4 we can write as it is plus 6x square plus 9 if we do, and minus x square if we write. Is it correct? 6x square minus 5x square minus x square makes 5x square, isn't it? And now if you see this particular term, this will make it a perfect square since it is of the form of a square plus twice ab plus b square, right? So this you can write it as x to the power of 4, x square plus 2 into 3x square plus 3 whole square minus x square. Can I write in this way? See? So is it of the form of a plus b whole square? Yes, it is of the form of a plus b whole square. So this you can write it as x square plus 3 whole square minus x whole square. Okay, so this makes difference of two squares. This is a square, this is a square, and in between you are having the negative sign. Okay, so this you can write it as x square plus 3 plus x, and this you can write it as x square plus 3 minus x is the final answer. Okay, so in solving this type of sums, okay, your one and only motive will be to express the terms in the form of difference of two squares. Like in the first set of sums I have told you, it was very easy to find out. First sum, you can easily identify that it is a perfect square, and accordingly you have used a square minus b square to find it. Next is like you have to take some term common in order to get the perfect squares. Okay, and in the third set of sums, like you have to add or multiply something. You have to add and subtract something in order to make it a perfect square. Means you have to somehow express the term in the form of a square plus twice ab plus b square. So it's not possible for me to solve all the sums related to this in a single class. Okay, so I have told you what is the method, what is the method behind it. I have already told you. Now the next is you have to practice a lot. If you practice a lot, then you will automatically gain the confidence in solving the sums. It needs a lot of practice to master these skills. Okay, so I have told you all the methods, all the possible methods. Compared to this, you have to, the main thing is that you have to make it a perfect square, either by taking common factor or by grouping or by adding something in order to make a perfect square or a difference of two squares. Okay, so I think this video is useful to you. If you find this video helpful, please subscribe to LearnGuru Classes, like, comment and share it with your friends and relatives. So thank you so much. Bye-bye.